Let's dive right into this explainer and follow the absolutely fascinating journey of a piece of software, from just a simple idea in a developer's head, all the way to a live working application. Think about it. When was the last time you refreshed your favorite social media app and bam, there was a brand new feature waiting for you? Or maybe you were playing a game and a super annoying bug was magically fixed overnight without you having to lift a single finger. If you've ever wondered how those updates happen so completely seamlessly behind the scenes, well, you were in the right place. We're going to take the highly complex world of DevOps and break it down into very simple, detailed steps. So here's a crucial question. Why did software updates used to take up to 8 months to release, but now they can literally take just minutes? For years, the whole IT industry suffered from this massive speed problem. Developing a piece of software and actually getting it onto a server where you, the user, could actually touch it was a painfully slow, conflict-ridden process. Honestly, it was a complete nightmare of miscommunication. You had people working in entirely different buildings, using completely different sets of tools, and constantly pointing fingers at each other when things inevitably broke down.
To understand how we fix this mess, we have to look at the old way versus the new way. The traditional approach was called the waterfall model. Imagine building a house where you can't actually see any of the rooms until the roof is completely finished. You plan the whole shebang, you code it, package it, and then, months later, you finally test it. But what if there was a critical bug? Or what if the client completely changed their mind about the living room? Well, you had to start all over again, adding another 2 to 4 months of delays. No way, right? The modern approach is the Agile model. Agile is like building that exact same house, but out of Lego blocks. You build a small section, and you immediately check if you like the shape after every few blocks. We test continuously, getting constant real-time feedback. This exact mindset is what takes us from months of agonizing delays down to deploying code in days or even minutes.
Okay, so here's our roadmap for today. 1. The software speed problem. 2. Writing and checking code. 3. Building the application. 4. Publishing the final artifact. 5. Deployment and continuous monitoring. And 6. The magic of Jenkins. Let's get into it.
First up, Section 1. The software speed problem, from months to minutes.
Back in the old days, the development team worked in their own isolated silo, just writing code. Then, they'd essentially throw that code over a metaphorical brick wall to the operations team, who then had to figure out how to actually make it run on the servers. To solve this, we merged the teams into DevOps and created what we call a pipeline. Think of a pipeline exactly like an assembly line in a car factory where the car moves automatically from station to station. This continuous integration and continuous deployment, or CI/CD, pipeline is fundamentally just 4 macro steps that run on a continuous loop. You write the code, you build it into a functional program, you test it to make absolutely sure it works, and you deploy it to a live server. Continuous integration simply means constantly blending new code into the main project, while continuous deployment means automatically pushing that code out to the users. Our goal isn't just to write the code. Our job is to automate this entire factory floor so humans don't have to manually pass the work along.
Moving right along to Section 2, Writing and checking code, the local journey.
So our code's journey actually begins as raw text. Imagine 3 developers sitting in totally different parts of the world. One's typing out the code for a main web page, another is working on a payment gateway, and the third is handling customer orders. Before their raw text is sent to a central hub like GitHub to be merged together, we have to check it. We use a process called linting. Linting is just like having an automated spell checker in Microsoft Word that highlights bad grammar, but, for code. It automatically scans the raw text for formatting errors, bad spacing, or, and this is a big one, accidental secrets. You absolutely do not want a developer accidentally typing a real, live database password right into the source code. Once it passes the spell check, we do a PR, or product review, which is a final human or automated quality check. Only then is our code finally allowed to move to the next station on the assembly line.
All right, Section 3. Building the application, turning text into action.
Okay, so the code is approved, but it's still just human-readable text. And as you know, servers don't speak English, and they certainly don't speak programming languages like Java. They speak binary, 1s and 0s. This is where a process called compiling comes in. Compiling is exactly like translating a book written in English into a language that only computers can read. A tool like Maven steps in, takes the raw text and builds or translates it into a machine-executable binary. But it doesn't stop there. Immediately after translating the code, it runs a functional test using a tool like JUnit. For example, if you just coded a basic calculator application, JUnit will automatically run a test to verify that 2 times 2 actually equals 4. If it suddenly equals 5, the assembly line instantly stops and the code is sent right back to the developer. No more waiting 4 months to find out the basic math is wrong.
Next up, Section 4. Publishing the final artifact,
packing the backpack.
This brings us to a massive concept in DevOps, the artifact. Think of an artifact exactly like packing a backpack for a long wilderness trip. You don't just pack your laptop, right? To be fully functional out in the woods, you have to pack your laptop charger, your mouse, and maybe a power adapter. Without those dependencies, your laptop is pretty much useless. An artifact is precisely that, an all-in-one, self-sufficient survival kit. It's a bundled package that contains your core executable code, plus absolutely all the necessary support files and libraries it needs to run completely independently on any new server without crashing.
But before we completely zip up that backpack, we have to run SAST. That stands for Static Application Security Testing. Remember those extra libraries and support files we packed? Well, many of those are borrowed from third parties on the internet. SAST checks those borrowed libraries for known security vulnerabilities. Let me give you a fun analogy. It's exactly like making a fruit salad. Before you mix your own freshly picked apples with a banana you bought from a random store, you check that store-bought banana for mold, right? SAST ensures you aren't packing compromised, moldy code into your final survival kit. And we call it static testing because the code is sitting still. It's not running yet. We're just carefully inspecting the raw ingredients.
Now for Section 5, Deployment and Continuous Monitoring, going live.
With our secure, fully packaged artifact backpack ready to go, tools like Ansible or Docker take it and finally unpack it onto the live production servers. But just when you thought the testing was over, it continues. Once the application is live and running, we perform DAST, Dynamic Application Security Testing. If SAST was checking the raw ingredients of our fruit salad before cooking, DAST is taking a huge bite out of the finished, baked cake to see if it actually tastes right. It's actively trying to break into the bakery while the doors are wide open for business. These tools dynamically attack the live, running software, looking for real-world security gaps. And at the exact same time, monitoring tools are constantly watching the software's health, making sure it isn't crashing under the heavy weight of real users.
So as we've seen, testing isn't just one single massive step shoved at the very end of the process like it was in the old days. It's a relentless, multi-layered filter applied at every single stage of the assembly line. Local linting catches typos and accidental passwords early. The build stage catches broken logic and bad math. The publish stage catches bad external libraries before they are ever packed. And the live stage catches active vulnerabilities right on the server. By the time code makes it all the way through this pipeline, you can truly, absolutely trust it.
And finally, Section 6, the magic of Jenkins, the ultimate orchestrator.
We have covered an incredible amount of complex tools. GitHub, Maven, JUnit, Ansible, Docker, SAST, and DAST. But we really need to answer one vital question. Who pushes all the buttons? I mean, if humans were still manually downloading code from one tool, typing out the commands to pass it to the next, taking that binary and handing it to the security team, and then literally emailing files back and forth to the operations team for deployment, it would be exhausting. It would still take months. The massive pain of manual handoffs would entirely defeat the purpose of having these fast tools in the first place.
Enter Jenkins. Jenkins is the ultimate manager and orchestrator. Think of Jenkins as an invisible, tireless robot conductor of a massive orchestra, and this robot conductor never, ever sleeps. As a DevOps engineer, you configure Jenkins exactly once. From then on, the exact second a developer hits save on their laptop, Jenkins starts waving its baton. It automatically tells Maven to play its instrument and build the code. It reads the test results. If it passes, it signals the security tools and the deployment tools to join in. It connects every single separate silo into one seamless, completely human-free performance.
The really crucial takeaway here is this infinite loop of DevOps. Because our robot conductor automates all the handoffs, we achieve true continuous integration and continuous deployment. And I really want to emphasize the word continuous here. Software in this modern model is never truly finished. It is a living, breathing thing. Constant monitoring from the live servers feeds right back into new ideas for the developers. They write new code locally, and the loop spins again, ensuring the software evolves securely and effortlessly.
And that brings us to the end of our journey. We've gone from a rigid, conflict-heavy nightmare that took the better part of a year to a fully automated, highly intelligent assembly line running on an infinite loop. I want you to pause for a second and just let the scale of this sink in. If a complex software update, complete with intense security checks and functional testing, can now happen entirely automatically in under 30 seconds, what limits how fast humanity can innovate tomorrow? The pipeline is built. Now the only limit is our imagination. Thanks so much for learning with me today.